Welcome to Study Loop.
We're told a baseball diamond is a square with side of 90 feet. Batter hits the ball and runs towards first base with a speed of 24 feet per second. In part A, we're asked at what rate is his distance from second base decreasing when he is halfway to first base. To understand this question, first I'll draw a diagram. So I'll draw a square. This is our baseball diamond. Then we have between home and first base, this is our runner, in red. Now I'll label the distance from the runner to first base of length x. The length from the runner to second base I'll call y. Now we know the distance from first base to second base is 90 feet. And therefore, by Pythagorean theorem, we know that 90 squared plus x squared equals y squared. We're also told that the rate at which the runner is running towards first base, dx dt, well, this is 24 feet per second, and so dx dt is negative 24 feet per second because x is decreasing as the runner gets closer to first base. We want to find the rate at which the distance from second base is decreasing. In other words, dy dt. To find dy dt, I'll use implicit differentiation with respect to t. We have that 2x times dx dt equals 2y times dy dt, and therefore dy dt equals x over y times dx dt. Now, because we're halfway to first base, it follows that x equals 45, and therefore y is equal to the positive square root of 90 squared minus plus 45 squared. And this is 45 root 5. And therefore follows that dy dt is equal to 45 over 45 root 5 times negative 24. And this is equal to negative 24 root 5 over 5. And this is in feet per second.
So praxis would be like, I don't know, apologizing for being racist.
Then in part B, we're asked at what rate is his distance from third base increasing at the same moment. So this is a similar idea.
I think that's a big part of me too. It's about being in a rough trade gay sex. As praxis. When you're getting your ass blown out.
So once again, I'll draw a quick diagram. This is our baseball diamond. And we have our runner here halfway between home and first. I'll call the distance from where he is to first base. I'll call this distance x. And the distance from where he is to third base, y. Now, to find the distance, we need to kind of know this distance here between first and third base. Well, because this is a square with side lengths of 90, This hypotenuse here has a length of 90 root 2 by Pythagorean theorem. And therefore, by Pythagorean theorem again, or there's an alternative approach.
Mom, fire up those hot pockets. I had a good day today. We're gonna celebrate by watching.
Instead, I'll let the distance at which the runner is getting further away from home, I'll call this x, and the distance from third base y. So now we have a proper right triangle here. This has length 90, and therefore, once again, we have x squared plus 90 squared equals y squared.
Incels are bad, not because they're virgin. No, they're bad. That's why.
Now, in this case, x is increasing because the runner is running towards first base. And so dx dt is positive 24. And again, well, at this instant, we're saying that x is equal to half of 90, which is 45. And therefore, once again, y is equal to 45 root 5. Now, in order to find dy dt, this is what we want to find. Once again, we have to use implicit differentiation, so we get 2x dx dt equals 2y dy dt, differentiating both sides by t, and therefore solving for dy dt. Dy dt equals x over y times dx dt. Plugging in, this is 45 over 45 root 5 times positive 24. And this is equal to positive 24 root 5 over 5, and this is in feet per second. And so our answer is simply the opposite of our answer from part A.